Sorry about that. 6 times 4, 24. I over n plus 4. Okay, so now that I have this full thing expanded, I'm going to go back over here. And I've still got the limit, n approaches infinity. This is your f of x sub I. Let me get that clear for you. This one down here. So I'm going to put it right here. And I'm going to sort of draw a line separating it so you can see. So I have 32 I to the third over n to the third plus 48 I squared over n squared plus 24 I over n plus 4, and then I need to do all of that times delta x, which is 2 over n. Okay, so then as you'll recall, we want to just kind of get the i's by themselves, so I'm going to pull this 2 over n in front of the sum. And then I'm trying to decide whether to split it up now. I think it's fine to split it up now. We'll just sort of do a big thing here. So here we're going to have 32 I to the third over n to the third. So as you can see, this is different from the other one because you're actually having multiple parts that you're doing the sum of. And so what you need to do now is for each one of these, pull away everything except for I. Except for this constant, so be careful with the constant. Okay. Okay, so here we go. Limit n approaches infinity. We still have 2 over n out in front. And then from here, we have 32 over n to the third. And then it's the sum of I to the third, 48 over n squared, and the sum, oh, that was supposed to be I squared, of I squared plus 24 over n, the sum of I. And then this one, the sum of a constant, is also something that you still need to make sure you do the sum of. Okay, so I'm glad we're finally having some space down here because we're going to need it. All of these sums with the i's, you need to replace them with what they equal from the page before. So I am going to pause the video and I'm going to go ahead and put what each one equals, and then we'll pick up where we left off. Okay, so you'll see that what I did here is the sum of I cubed. I just used the textbook and you can see what it equals. I squared I wanted you to see me do this one. The sum from I equals 1 to n of 4 is the same as 4 times n. So you need to make sure that you understand, because basically this is saying going from 1 up to n, how many 4s would there be? So 4 times n would be the total sum. Okay, so from there, what you're looking at is that you basically want to do the limit. Now, to be honest, Okay, so from there, you would basically need to expand all of these separately, and you need to do the limit as n approaches infinity for each of them. To be honest with you, this is where I'm going to take some liberties because this video is already quite long, and I'm going to sort of show you how I do this, maybe without expanding everything. So the first one is this. So I am going to write all of those. Sorry, 2 over n. 2 over n times 32 over n cubed times n squared n plus 1 squared over 4. Okay, that's the first one. Now notice this 2 over n has to go with each one. So then this next one's going to be the limit as n approaches infinity. Again, 2 over n, 48 over n squared. And then you've got n plus 1, 2n plus 1 over 6. Okay, plus limit. Alright, you get the idea. I'm going to pause it and I'll come back when I've finished writing all of these. Okay, so not great format, but you'll see here that this term, you need the 2n in front, and then this one, again, you need the 2 over n in front. So now I'm ready to do each of my limits individually, and what I'm going to do is sort of talk about how you can see without doing the whole thing. So what you want to look for is the power on the top and bottom. Remember, with limits to infinity, you're always concerned about where's the power higher on the top or bottom. So in this case, I've got n squared, and then this n is also squared. So n squared, the highest power on the top is n to the 4th. On the bottom, I've got n cubed times n, that is also n to the 4th. So in this case, I can already tell that the power on top is n to the 4th, the power on the bottom is also n to the 4th. So if the powers on top and bottom are the same, all I actually care about is the leading coefficient. So to do the leading coefficient, you need to do all the numbers, and then if there's any coefficients in front of your n's, you would need to do those as well. So in this case, I'm going to do 2 times 32, which is 64, and then on the bottom I've got 4. Okay, so here I'm going to try and evaluate it sort of the same way. So in this case, I see I've got n times n times n. So on the top, I know I'm going to have n to the 3rd. On the bottom, I've got n squared times n, so also n to the 3rd. So all I care about again is the leading coefficients. So in this case, on the top, I have 2 times 48, and then I'd also be multiplying by 2 again here. So 2 times 48 times 2 is 192. So that's for the top. On the bottom, I just have 6. So here I've got n times n, that'll be n squared. On the bottom also n squared, so 2 times 24 is 48 over 2. And here I've got n, so it's going to be 8 over 1, or just 8. And you can see how that cuts down many steps. There's really no reason that you would need to multiply this all out unless you're having a really hard time seeing sort of what the limit would be. So in this case, now I'm ready to add all my answers together, and I can just use a calculator for that. So let's do that. 64 divided by 4 plus 192 divided by 6 plus 48 divided by 2 plus 8 equals 80. And again, check your answer by doing the actual integral. So I've got 4x to the 3rd, and then down here I've got from 1 to 3. And indeed it is 80. Okay? So if you had any trouble understanding sort of this step, how to get from here to there, definitely let me know, and I can explain it again.